All right, in this video, I'm going to show you how to get a physics degree in 10 minutes, or at least I'm going to show you my physics degree in 10 minutes, or around that time anyways. I'm making this video to show you that earning my degree did help me and show me how to solve software engineering problems, but a degree isn't the only way that can teach you how to solve software engineering problems. You can learn to code by yourself. You can watch courses on it. There's plenty of free courses online. You can make projects. The best way to really learn, I feel like, is to do your own projects so that you can learn from your mistakes. And that's really the key in learning and helping you solve your own software engineering problems. So I'm going to tell you how you can emulate these problem-solving skills of a physics degree and to help you be a better problem solver. So whether you want to go into a career such as software engineering or maybe any other career like data scientist or mechanical engineering, the sky is your limit if you can solve problems, really. And you can probably think of one of the most popular billionaires in the world at this time, Elon Musk. He had a degree, I think he double majored in physics, which I majored in. Not the reason I majored in physics, by the way, but also like in economics or something like that. And he has a really great understanding of the world, of course, because he has two really great companies, SpaceX and Tesla. But of course, just majoring in a degree in physics doesn't translate directly into building rockets and driving cars. But it's a decent start, and that's really all you need. And a lot of work. And my first tip for those that want to learn how to be a software engineer without a college degree is to triple click that like button so you can help me with the YouTube algorithm. I was just joking on that one. But before I graduated, I always was joking around that I had a theoretical degree in physics. I think it was like some joke off the Big Bang Theory or something like that. I've never really seen that part of the Big Bang Theory. But now, too, you can get a theoretical degree in physics if you get to the end of this video. So I say hint of computer science in the title because I took most of the computer science classes, like programming 1, 2, data structures, algorithms, discrete math. So I took the main algorithms that are really important for interviews. The rest are kind of like, cool and stuff like that. But I was one class away from getting the minor, and I thought it wasn't worth it to continue on that path. Like, it would probably take me another year to finish with a double major in computer science and physics. So I took like the most important class, honestly, that most computer science majors think is important for their major, and that's data structures and algorithms. So I didn't see a point of continuing with that. So I didn't think it was worth it because another year probably would have cost me like, I don't know, $10,000 or something like that. I would have to take out another loan. And then I knew I could find a job eventually. Like eventually I did have to go like a coding boot camp, which is fine. Like it helped me get a start in my career. So I think it's fine. So it probably would have helped me find a job a little bit faster if I did have a job, a degree in physics. Sorry, I do have a degree in physics. I mean a degree in computer science. Because then I wouldn't have to probably not have to go through a coding boot camp because they would probably think, oh, this guy already knows how to code, instead of going through more like a technology boot camp is what I like to call it, with like teaches you like technologies like React, Spring, Express, like server-side and client-side technologies. And that, of course, helped me place me in a job. All right, so now onto my degree. So my college degree kind of started before I even went to college. Because before I went to college, I took like 17 AP classes, which if you don't know what AP classes are, they're advanced placement. They basically give you credits for college. So of course my AP classes got rid of most of my general education requirements like biology, English, chemistry, calculus, at least calculus 1, and stuff like that. So by that time, I felt like a junior of credits. Like that's what people memed, like, oh, I'm a junior of credits. But my physics professor or advisor advised me, oh, you got to take the honors physics classes. This is the biggest scam ever. They wanted you to take the honors physics classes because they'll help you later on the road. But I don't think it really helped me. So I took honors physics, and what really that showed me is that those were kind of like smaller classes with just physics majors instead of like, biomedical nonsense degrees, which is a good degree. So my first semester, I took Physics 1, Chemistry 2, Programming 1, and then Calc 2. So very all math, sciencey things my first semester, which probably was a bad idea because it might have stressed me out a lot. But I think Programming 1 was pretty interesting in my first, semester because I took like AP Computer Science in like high school, And it was kind of very different from what was taught in college. So it was kind of good. I took programming 1 again. And of course it was Java, which back in the day was most like used language or something like that. So I guess that's why they taught it. So we didn't really learn like many data structures in programming 1. We just learned how to, I guess, use for loops and stuff like that, how to declare variables, how to use private and public variables and stuff like that. And then kind of how to like write simple programs with it. That's really all we did there. And of course, in like chemistry and stuff, we learned how to, like put chemical equations together, which was really interesting. I should have become a chemist. So things got more intense my second semester when I took programming 2, which we switched over to C++, which was much more difficult. I remember we had to make a snake game in a team. And this was like the first real big team like project. So I guess that's what really helped me like learn teamwork a lot and stuff like that. And then of course I took more like calculus classes, which were kind of, now that I think about it, unnecessary for my career, which is software engineering now. But it did help me solve these intense 3D mathematical problems, I guess. And then I think I took like a MATLAB class to help me model data. And I thought MATLAB was pretty cool, even though like all the computer science majors didn't really like it because it's like baby programming or something like that. But it's pretty useful for modeling data. And I know some physics majors that went on to MIT, like for graduate school, they use MATLAB like to model like coronavirus data and stuff like that, which I thought was pretty cool. So then I had to take like French because I had to take a foreign language. Then I took computational linear algebra, which was required for, I believe, both physics and the computer science minor, which I wanted to go for, at least at that point. And the computer science, I could either take, I guess most physics majors took the regular linear algebra, which is much more difficult than computational linear algebra. But honestly, I don't even remember that much about linear algebra because it was all about like multiplying matrices. And it kind of had me recognize patterns, I guess, in matrices, but I guess that's really all I remember. And then I took a bunch of physics labs as well, which was really cool because I never did much hands-on stuff, like connecting a bunch of wires together and completing circuits and stuff like that. Made me think I should have become an electrical engineer as well. And then, oh man, differential equations I remember as well. I don't remember, I think in my second semester as well, I took it at the same time as Calc 3. And it's a like completely different like game from Calc 3, where Calc 3 you do like calculus 1 in 3 dimensions. Differential equations was kind of like solving these really interesting equations that probably I only solved in my physics classes. I doubt very many math majors actually solve those. So then I went on to take theoretical physics, which was I guess the honors version of mechanics 1. And that was probably one of the hardest classes I've taken. As you can imagine, theoretical physics was very difficult. And then I took electricity and magnetism, which was one of my favorite classes, honestly, because I really liked the wires and electricity and all the Maxwell's equations. Like when I was in high school, I wrote all 4 Maxwell's equations on the wall. And my dad like walked into my room like, what? Of course I wrote them on a piece of paper and hugged them up. But my dad walked in the room and he thought, he asked my mom, what are those equations? And I'm like, I didn't know what they were either at the time. I just knew they were important equations, and they are. And then I also took modern physics, which was really cool as well. Kind of showed you like relativity, general relativity. I really like those kind of things, even though like the only use for them like nowadays are kind of like in satellites, but at least they have some uses. So then I went to take electricity and magnetism 2, which required so much math. This is the part where I like decided I didn't want to be a physics major anymore, but at least I wanted to finish the degree. And I also took engineering writing because I think that was required for some, I think for an engineering degree, which I don't know. I was really confused at that point. So I took engineering writing class, but that actually helped me a lot. Like learn how to write essays and learn how to write emails and cover letters. So I mean, it helped me a little bit. I don't remember actually anything from the course. I don't know what am I talking about. All right, so then I think some semesters later, I took number theory, which was, I guess, a math class that I could take during the summer, which I thought was interesting. And it really was interesting, like finding the 4th square root of an imaginary number. Like, of course, I'm never going to use that unless I go back into like physics or something like that. But it was really cool to learn how to solve those weird problems that rarely anyone will know how to use. That's kind of similar to like many programming interviews. They kind of ask you to solve these problems that you're never going to use, at least most of the time. Like solve the nearest path to this and this. And if you really needed to learn how to do that, you could just look it up online. But they want you to know that you can have attained the knowledge to do so. And then I also took discrete math, which is really a really useful class that was required for a computer science minor. It was useful because discrete math had you like look at different logic puzzles, like and or something like that. And then I think that was probably one of the most useful classes to figure out the logic behind, like, I don't know, very logical discrete math. I like it. And then I took one computer science class. It was called computer organizations or something like that. And it basically went through kind of like how CPUs kind of like thought with like numbers. And then at the end we used like kind of learned how to do like very basic assembly language. I think it was like MIPS or something like that. And we kind of learned how to work on the very close to the, I guess, the hardware, which was really cool because I never really understood what went on like between like the electronics and then between like the higher level languages like Java. So I think that was really interesting to get a bigger picture. So then I took my last computer science class of, I guess, my undergraduate career, which was data structures and algorithms. This is probably one of my hardest classes I've taken because they asked us to like implement every single data structure in all of our projects. And I guess that was really helpful, but it was also really difficult to do alongside a bunch of really difficult physics classes like optical physics, in which we had to use mathematical equations to measure lenses and light paths, which was really cool. It's just very difficult. And then biological physics, which was nothing really about, I mean, it had to do with biology, but it was on a probably different level than what most biology majors thought of what biology was. And it was kind of like the kinematics of cells kind of in water, like how they can move randomly, which is really cool. And then I also took the advanced physics lab, which we made like, I made a random number generator out of like a little screen like this and a bunch of wires and like transistors and op amps, which is basically electronic stuff. And it was really cool. Took us a while to figure out how to make a random number generator. And at the end of that project, like my professor asked, "How does it work?" And then like I explained it, and he said, "Oh, it must be really random then," because I guess he was like assuming that I didn't know how it worked. So that's how it's random. So it's, job's done, right? Okay, now I want to go through some other physics classes, the higher level physics classes that I didn't really cover. And this is not necessarily in the order, but I took quantum mechanics, very difficult, but it really kind of showed me that there's a lot more of physics than just undergraduate. Like, I only took the first quantum mechanics, and there was a second one in undergraduate as well. But quantum mechanics kind of showed you that at the really small level, there's like a couple equations that will like govern everything. And you kind of really need to know those to understand it. I also took thermal physics, which kind of helped me understand heat, but I can't remember much about it off the top of my head, honestly. And then elementary particle physics. That was probably one of my most favorite ones. Because like when I was a freshman, I was most interested in it. So like I walked into like a class of seniors, like when I was a freshman, and there was like 5 people in that class, and like the professor let me sit in it because like he was a cool professor. And then I took it again like my senior year, and then it was like on the very basic level because there's like so many different particles, like hundreds of elementary particles, like bosons, like the Higgs boson and stuff like that. So that was really cool. But I mean, it was on a very basic level though, and I can tell that all of this could get really difficult to like calculate. During the final exam, they like asked us to do very basic calculations of like energy and mass with all these particles, which I knew this could get much more difficult if I went on to a graduate degree. And then I also took Mechanics 2, definitely the hardest class I've taken like ever in my undergraduate, because we had to do like very intense math. So this is where linear algebra probably would have helped me if I took linear algebra, but I didn't because they had us do this very complex like matrix mechanics, and I don't know. I was through with my physics degree at that point. Then I took the advanced physics lab 2, which was really cool as well because we worked with like liquid helium, liquid nitrogen. By the way, liquid helium is like 2 degrees Kelvin, which is like really, really cold. And then we also like detected particles falling in from space that you can't see, of course, but they're being detected with like this really big detector. And then I also took statistical physics, which is kind of like the sequel to quantum mechanics, but like having to do with thermal physics as well. But yeah, I don't know. I really enjoyed my physics degree. And I guess I probably would have majored in computer science if I knew where I would end up. But then again, it was fun, so I don't have any regrets. All right, that's the end of this video. I hope you liked it. If you did, could you subscribe to me, and I'll post more content. Probably not much more about physics, though, because physics makes my brain hurt. Not really. I'll see you later. Peace.